Hello, statistics student. This video is for chapter 1.3, part 1. We're looking at two big topics in 1.3, namely how to summarize quantitative data in a table and also how to do statistical experiment. So this part 1 is about summarizing quantitative data. In 1.2, we talk about if I have data that is categorical nature, then I can just count all the particular category and then build a table or do a bar graph or a pie chart, right? So we did that with the eye colors and the part-time status. Here I have a third data that I collect from students, and it is about the commute time. That means how long it takes them to come to DVC or come to college. So these are commute time in minutes, and these are obviously quantitative data because these are numbers. So unlike categorical data, I can count each category and summarize the count. Here I have different numbers, so if I count them, it's kind of difficult, especially for quantitative data that are continuous, because I would have different numbers. So occasionally I would have people that come, with commute time that is the same, but a lot of times they're all different. So counting a particular category or particular occurrence of a number would makes a lot of different categories and is not a good way to summarize data. So to summarize quantitative data, especially if it's a large database or data sets, we would summarize them into something called a group frequency distribution table. We still count frequency, but we group them in classes. So we classify data into classes, where each class can have a range of non-overlapping values, right? So a typical grouped frequency distribution table summarized as GFDT would look like this. You could have a range of data values like in grades 60 to 69, 70 to 79, 80 to 89, 90 to 99, and you count how many data are in this range. Oh, there's 2 data in this range. Oh, there's 3 data in this range. There's 12 data in 80 to 89. So you still do counting just like when you do your categorical data counting, but you count them, you tally them into classes. And sometimes if your data is quantitative but discrete data, that means the numbers does not vary as much as grades or commute time. They are like a number of siblings. Sometimes you have 0, 1, 2, 3, 4 siblings or more than 5. This kind of classes, you can count each class would be one number. So occasionally for discrete data, this is possible. So both of these are called group frequency distribution tables because you associate the frequency with the particular data range, and we call them classes. There's some terms related to GFDT, the frequency distribution table. So let's go through them. We'll use them later on to graph them and also do calculation on them. Okay, so the first term is called lower limit. It's the lower bound of each class. So if the class has one number, so we don't have lower and uppers limit, it's just one number. But if a class consists of a range, the lower limit is the lowest bound of the class, and the upper limit is the upper bound of the class. So lower limits for this table would be 60, 70, 80, 90. Upper limit would be 69, 79, 89, 99. So if the value is in 69, then it will be in this class, the highest number in the class. Class midpoint is the lower limit plus the upper limit. Add them together first, so I parenthesis them, and then divide by 2. So it's the middle of the class. So this will be used later on in chapter 2 in doing some calculation. So remember this term, class limit. Class width is how big each class is from each other. So not how wide each class is, but how much one class is from the other. From 60 to 70, both are lower class limit, so they are 10 apart. So it's the difference between two consecutive lower limits. So this class width would be 10. This class width will be 1. Okay, look at the lower limit and subtract them. Presumably, all frequency distribution classes should have the same class width. You don't jump around by saying, oh, this is different by 10 and this is different by 5. Usually they have the same class width. Class boundaries are the values between two classes. So there you would, in some cases, you see gaps between them, like 69 and 70. So if a number is 69.5, it would not belong to any class, right? So what happened is these are arranged in such a case that there is no number that's fall between 69 and 70. So class boundaries would be the middle between a lower class limit and upper class limit. So 69.5 is the class boundary. 79.5 is the class boundary between these two classes. Sometimes class boundaries are used for graphing, but it is not a very important terms. Okay. So when we summarize data, the first thing we summarize is frequency. So how many are in this range? How many are in this particular class? We can also build frequency table that specify relative frequency and cumulative frequency. So you run into relative frequency before. Relative frequency is the frequency over the total, right? So it's usually represented in percentage or in decimal. Cumulative frequency are concerned about counts of less than a number or more than a number. So a lot of time it's less than a number. So these are the two new frequency tables that we can generate from the grouped frequency distribution tables. Cumulative frequency tables are useful for finding number less than a number, number less than a values. So before we go into those, I have a rounding review that I want to go over because when we calculate relative frequency, a lot of time we have to do rounding. So the rounding rule is if you are rounding to a certain place, you look at one place more, the number that is following that particular place that you're rounding. If it is 5, 6, 7, 8, or 9, you round the number up. If the number place you're rounding to is followed by 0, 1, 2, 3, 4, you round the number down. That means you just drop them. Say, for example, if I want to round these into 3 decimal places, so I would say I want only 3 places. So I'm not supposed to write all of them out. I am to write 3 places only. So that would be the place that you look at. And then you look at the one that you are rounding that's following it. So this is the last place that I want to write down. And I look at the one that's following it. 8 is greater than 5, so I need to round up. So this become 0.127 plus 1 is 128. Okay, not because of the 8, but you add 1 here. And for this one, if I do 3 decimal places, this is the place I want to round to. The one that's following it is a 3, but it is less than 5, so my number will be round to 0.128. You do not care of all the other numbers following it. Sometimes in the calculator, you have 10 numbers following it. You don't care. You only look at the number that is immediately following the place that you want to round to. What about 0.1239? So 9 is greater than 5. So I want to round to 3 places. So I want to add 1 here. So this would be 0.124. Okay, I'll round it to 0.124. What about this? This is the place I need to round to, but the 8 following it is greater than 5. I am supposed to round up. So I add 1 here. If I add 0.129 plus 1 on this place, it will become 0.130. Do not write 0.13. It should be 0.130 for 3 places. What about if it is 5 over 6? So if you use a calculator and divide 5 divided by 6, it should become 3, 3, 3, 3, a lot of 3 following it, but you only want 3 places. So you look at the third one, and the one that's following it is less than 5. So this would be 0.8333. I want to run decimal place for a percent. So for percent, you write it as a percent first. So it'll be 11.84%. And then you say, I only want 1 places of a percent. So I do 11.8% because 4 is less than 5. Similarly, this is already a percent. So I don't need to do anything. So I just want to do 1%. So that will be 45 point. Should I add 1 to 6? Yes, because 7 is greater than 5. 45.7%. 52 out of 89 is not in decimal or percent, so I would do 52 divided by 89. In the calculator, it shows 0.584269 along places. In percentage, is 58.4269, right? But I only want 1 decimal place of a percent, so will be percent. So it'll be 58.4% because 2 is less than 5. Round to the nearest whole number. Sometimes I want to round something to the nearest whole number. So 12% of 781. Remember, something of 7% of this, I would do a multiplication. 12 times 781. 0.12 times 781, it is equal to 93.72, but I want a whole number. Whole number is here. So 7 is greater than 5, so that's rounded to 94. What about this? 15.2% of 2344, so that is equal to 0.152 times 2344. So that would be 0.152 times 2344. I got 356.288. I wanted to round to the whole number, so I only want this number, the place of rounding. 2 is less than 5, so I only write 356. So this is the rounded whole number. So to calculate relative frequency of a class, say for example here I have this. 2 is in this class, 3 is in this class. What is the percentage of 2 out of the total? So what you want to do is you want to do the frequency over the sum of all the frequency. That means total sample size. What is cumulative frequency is sum of the frequency for that class and all previous classes. So let's do an example. Do we have enough time that we can do an example? So maybe we'll do this. What is the relative frequency for a commute time, or maybe whatever time that it is? I don't know. I don't think this is commute time. This is something else. Oh, I think service times of a fast food restaurant. So we want to find relative frequency. So would be this frequency over the total. So first of all, we have to find the total frequency. Sometimes they don't give it to you. You have to calculate this. So this would be 11 plus 24 plus 10 plus 3 plus 2. So that's 50. Oh, that's easy to do. 50 is a good number. So relative frequency would be 11 over 50, right, in a percentage. 24 out of 50. I think that's easy to do. It's 22%, right? And this is 48%. So this is 10 out of 50. That is 20%. And this is 3 out of 50. That is 6%. 2 out of 50, because this is a good number. So this is 4%. What about cumulative frequency? Cumulative would be less than. So this is 75 over to 124. They're all less than 125. So cumulative 11. What is the second one? They're all less than, because this would be, both of these are all less than 175. So you say less than 175. So that would be 11 plus 24, 35. So you keep on adding them until you have the total here. Or